Hello and welcome to Python Programming Complete course. This is part 14, Recursion in Python. In this video, we will discuss what is recursion, types of recursion, how to write a recursive function and how recursion and iteration are related. While discussing user-defined function in Python, we have already learned how a function can call another function. Talking about recursion, recursion is a programming technique or concept where a function calls itself. Now, these types of constructs of functions are called recursive function. Take for example this function call xyz. It is a function, a user-defined function. It has some statements, statement 1, 2, 3, and in the main part we are calling this function. We are making a function call. But if we look at this line call xyz, inside the function itself we can observe that this call xyz function is calling itself. Now this type of calling is known as recursion, where a function calls itself. Recursion is of two types, a direct recursion and indirect recursion. Talking about direct recursion, if a function calls itself directly from the function body, it is direct recursion. For example, in the same example where call xyz function, it is calling itself. We have one more example. This is an example of indirect recursion, where a function calls another function which in turn calls the caller function. For example, we have two functions, call xyz and call abc. Inside the main part we are calling call xyz function. Xyz function is called, these three statements they are executed, then it is calling another function call abc. Control is transferred to call abc. Call abc, statement 1 and 2 they'll be executed, then it is calling its caller function. Its caller function is call xyz. Such type of calls, they are known as indirect recursion, where a function calls its caller. Some common examples where recursion is used is to calculate the factorial of a number, or power of a number, to reverse a string, or to calculate the sum of n natural numbers. While writing recursive function, care should be taken to avoid the function running indefinitely, or we should avoid that a function goes into an indefinite loop. So a recursive function must have two important things, that is a base case that stops the recursion and must be reachable for some argument, and a recursive case where a function calls itself. For example, if we talk about these two points, let's discuss this program, how to calculate the sum of n natural numbers. So we have taken a number n, where we want to calculate its sum, the sum of n natural numbers. We are calling a function sum with an argument num. It will return some value, it will be stored in total sum, and we are printing it. Inside the function body, we are checking if number equals to 1. We can directly call the sum number inside the function itself as a form of a recursive function, but we are checking if number is equal to 1. Initially it will return 1, or while recursion the number reaches a value of 1, then 2 it should stop the recursion and come out of the function definition. It should come out of the function and return the sum to the main part. In the else part, we are again calling the same function with a different value, that is 1 less than the original number, and every time it is being called we are reducing the number by 1. So initially the value is 5. The function is called with a value of 5. It is not equals to 1. It is not a base case. It will come in the else part. There the function is called again with value 1 less than the number. Plus we are adding the number also. Why? Because when we want the return value, we are trying to calculate the sum. So recursion function works by creating a function stack or a function frame, where each frame is an invocation of a function call. If we talk about that, so for initially my function is called with sum 5. Next time when it calls itself, it will be 5 plus sum 4. Next time 4 plus sum 3, 3 plus sum 2, 2 plus sum 1, and finally with a value of 1. It will be placed in internally. It will create a stack like a pile of book, and it will keep each function on top, each function call on top of each other, and when that working is being done, it will return a value. It will take out one return value from the top of the stack and will finally give me the sum of these total of these natural numbers. That is, in our case we are taking 5 as the value for which we are trying to calculate the sum. So let us execute this program and see the result. The output could be seen. Sum of 5 natural numbers is 15. If we change this value, say we make it 1, let's save and execute. You could see the base case is being met, number equal to 1, so it is returning the sum of first one natural number. It's 1 itself. If we make it as say 2, let's see the output. First two natural numbers, it's 3, that is 1 plus 2. We are getting an output of 3. So what happens if the base case does not happen or it is not met? Then our program goes into an infinite loop. It will run indefinitely. But if we talk about Python, the Python interpreter limits the depth of recursion to avoid or to help avoid indefinite recursions, resulting in stack overflows. So if you are trying to run a recursive function where there is no base case or the base case is not met, then by default the maximum depth of recursion is 1000, and if that limit is crossed, we will get, or it will result in a recursion error. This program is an example of indefinite loop where we will get an recursion error. If I execute this program, we have one function print again, which will print computer science. It will call itself again and it will run indefinitely because there is no base case, only a recursive case is present. So you could see computer science being printed again and again, and finally if I scroll down, you could see the previous lines are repeated more than 9, this, and we are getting an error, recursion error, maximum recursion depth exceeded while calling a Python object. So we are getting a stack overflow condition which will, and it is resulting in a recursion error. Talking about the advantages of using recursion, it makes the code look simple and elegant. Another advantage is complex tasks can be solved easily. Now there are some tasks that can be done in an easier way using recursion compared to iteration. One such example is calculating the factorial of a number or to calculate the power of a number, but there are disadvantages as well. Logic is hard to follow and debug for some, and it takes a lot of memory and time as a stack needs to be maintained if we are using recursion. We have one example, a very classic example, where factorial of a number is being calculated using recursion. So in our main program, we are assigning a value to a variable and we are calling the factorial function. Inside the factorial function, I am printing the value of x, so that we can see that each time the function is being called, it is calling itself, then the value is changing. We have a base case where we are checking if x equals to 1. If a base case has been reached, then the function will stop. Else, in the else part, we are making use of recursion. We are calling the factorial function again with a value less than the value of x, and definitely since we are calculating the factorial, so we are multiplying it with x. Let's execute this program. Initially the value of x is 5, then 4, 3, 2 and 1. So 5 into 4, 20, 20 into 3, 60, 60 into 2, 120, and then into 1 we are getting the factorial of 5 as 120. It is always said that which one, or it has always been debated which one is better, recursion or iteration. Then let's discuss this as well. They are related concepts. Any problem which can be solved using iteration can be done using recursion and vice versa. But there are specific problems which are better or which are best solved using recursion. Only problem with them is that they are slow and more memory is being used or consumed than the iterative counterparts. The same factorial program this can be solved using a while loop or a for loop as well. This is the same program, but in this we are calculating the factorial using a for loop instead of recursion. We are making use of range and we are multiplying the value of I with the factorial and getting the result. If I execute this, let's see the output of this program. I'm printing the value of I, and if we talk about the result of this, factorial is 5, 5 into 1 is 5, 5 into 2, that will be there, and multiplied by 3, then multiplied by 4, and finally we are getting the factorial of 5 as 120. In this video we have discussed what is recursion, different types of recursion, and how to write a recursive function having a base case and a recursive case. In the next video we will discuss linear list in Python. Hope you found the information shared in this video useful. Stay tuned for upcoming videos and thank you for watching.